Hello, everyone, and thank you for joining us. My name is Samantha Johnson, and I am the Assistant Director of Alumni Engagement at the University of Colorado Boulder's Leeds School of Business. Leeds is a top business school offering undergraduate, MBA, MS, and PhD programs and has an alumni network of over 41,000 strong living and working around the world. We're excited to have Manuel Laguna presenting on improving business efficiencies with data analytics for today's webinar. Just a few housekeeping items before we begin. First, if you have any questions now or during the presentation that you would like to ask Manuel, please send those questions through the chat interface. I will monitor questions as they're submitted, and Manuel will respond to them at the end of the presentation. As a reminder, for optimum audio quality, we do have everyone on mute except for myself and our speaker. If you experience any technical difficulties during the webinar, please notify us through the chat interface and one of our support specialists will touch base. Lastly, a link to access the webinar recording will be sent to all registrants later today along with a survey link. Now, I'd like to introduce today's speaker. Manuel Laguna is the MediaOne Professor of Management Science and Director of Global Initiatives at the Leeds School of Business of the University of Colorado Boulder. He started his academic career at the University of Colorado in 1990 after receiving a master's and doctoral degrees in Operations Research and Industrial Engineering from the University of Texas at Austin. He has done extensive research in the interface between computer science, artificial intelligence, and operations research, resulting in over 100 publications, including 4 books. He has received research funding from private industry and government agencies and is the co-founder of Optech Systems, a Boulder-based software and consulting company that specializes in the optimization of complex systems. He is the editor-in-chief of the Journal of Heuristics and has been division chair, Senior Associate Dean, and Interim Dean of the Leeds School of Business. Welcome, Manuel, and thank you so much for being here.
Thank you, Sam. Just gonna thank you for that nice introduction. So for today's, and welcome all of you, good morning. For today's webinar, the only thing I will add to that nice introduction is that I'm currently teaching in our Masters of Science in Business Analytics program, and that's the Survey of Business Analytics course, and that's where I have based this what I'm going to share with you today. So let's get right on this on the topic. So business analytics, as you probably know, the idea is to use data to make better decisions. So what we're going to address today is the 3 levels of business analytics. We have, and the way I order this is in the level of complexity. So descriptive analytics is mostly statistics and visualization and those types of tools that help companies understand the past and the current performance of their businesses. Predictive analytics is 1 level up in terms of complexity, where we start building models to make predictions, and I'll show you and discuss a few of those with a couple of examples. And then prescriptive analytics is where I have spent most of my career really doing, and that has to do with optimization. Is the main tool in operations research, and that's essentially what I have focused on in most of my career. So let's talk about just business analytics in general. The approach is a very integrated approach from different areas. If you think about it, and you'll see today some of that, or if you have read about analytics, you will see that statistics is a fundamental kind of topic that is the foundation of analytics work. But then you have things that come from both computer science and operations research, and those are tools like data visualization, data mining, simulation, and then of course decision modeling and mathematical modeling and optimization. That's definitely coming from operations research. So let's jump right in and talk about data exploration. So I'm sure everyone has heard this idea of a picture is worth 1,000 words. So let's see how that will work and how that applies to data analytics. And the way we're going to conduct this this session is that I would like to introduce an example. Then we talk about the data that will be related to this little situation that I try to make as real as possible, and then the tools that are associated with answering these questions or dealing with the little scenario that I present to you. So let's look at this one here. So let's say there is a bank that has current clients, and that what they want to do is to increase the number of clients that have personal loans, and they want to engage in a campaign where they're giving incentives or advertising personal loans for their current clients. All right, so but they want a campaign that is effective. So remember, our title here is efficiency, and efficiency is all related to the best use of resources under some constraints. So, okay, what kind of data would they need? Well, let's suppose that they have demographic data, the one I listed there, and then they have some financial data that is related to the accounts they have, whether they use online banking or and then maybe what is the balances in their credit cards. All right, so in business analytics, it's not always about jumping right onto building a model and creating some very complex mathematical modeling tool. You can start with something simple like data exploration. And for this problem, for example, for this situation, that may mean something like this. For example, scatter plots are very common, right, in statistics and just to show data. And these scatter plots, in particular this one here, what it shows is on the y-axis you have the income of each point here represents a client. You have income here in the y-axis. You have the average credit card balance in the x-axis, and then you see some relationship that maybe is not shocking, right? You have more income and perhaps higher balances in their credit cards. Okay, so you say, well, how is this going to be helpful to the situation at hand, which is figuring out who might be the right person to approach, the right client to approach, advertising personal loans. Well, sometimes it takes something very simple, like just coloring something like this. And so this is what I'm showing here in the next chart. So you see, this is the same scatter plot, but now what we've done is we have colored each point where the dark points are people who have taken personal loans, and the light blue is people who have did not respond to the last campaign. So now you have at least some insight, right? I mean, we can see here that we have an area, a total area here of income of less than $100,000, and average balances of less than 3,000, that they don't seem to they didn't respond at all to that last campaign, and perhaps these are not good clients to approach. So just one very simple thing gives you an insight on what's going on in this particular situation. So let's see another example where we're not building models, we're just exploring data and using visualization tools to gain insights on what's happening. So think about these other ones. So let's suppose you have a customer retention situation where it's a telecommunications company that is concerned about losing customers. And so the company needs to understand who's leaving and develop some sort of customer retention programs. All right, so let's see what data they may have. So let's suppose that they have demographic data and what kind of services these clients have secure, and also some data on their accounts. All right, so one possibility, and this is very common for tools in data analytics, is that they will give you what in a data set is important. Because in a data set you have all these different variables that you are collected. There could be many, and the idea is to find what's important. And here, in a statistical terms, that's something that will be called correlation, just finding what is more related to the output variable, which is this churn. Churn indicating whether a customer is still with the company or the customer has left. Okay, so this here just shows that tenure, so how long the customer has been with the company, seems to have a big predictive power in terms of who's going to stay and who's going to leave. Because it has, this score here, let's call it 73%, and then you have some other things that are also important, like type of contract and services. All right, but we need to get more insight on, for example, what tenure really does to churn. So this chart now gives you additional information, right? Because now we say, all right, this is a bar chart where in the x-axis we have the months that customers have stayed. So this is just a simple count of customers have stayed less than 6 months or equal to 6 months, up to 20 months, 40 months, 60 months, and more than 60. So what now we can see here, by separating those who are still with the company, which are the black bars, and those who have left, which are the light blue bars, is that clearly there's a trend here where the longer they stay, the less likely it is that they're going to leave. And then the flip side of that is that the longer they stay, again, these are the ones that are not leaving, and of course these are the ones that are leaving. So the bars are moving in opposite directions, and indicating that we had to worry more about people who are just started with the company and have very short tenures. All right, so this is just exploration, but how about something more sophisticated, something that gives you something that goes beyond pictures? Well, let's talk about predictive analytics then. In a prediction process I'm trying to picture here sort of in a very linear way, but one has to remember that that is not necessarily as straightforward as it may look in this picture. And that's because analysts will have to stay in this area for a little longer than sometimes they want, which is you have historical data and building models, and validating these models with this historical data could take a significant amount of effort, depending how good the data are, and then how well these models adjust to this data. But the point is, once these models are built, is that that we want to use them to predict what will happen with new data. Two tools that are very common are classification trees and regression. We're not going to talk about regression. I'm going to tell you a little bit about classification trees, because I think it's just they are very commonly used, and you might find them interesting. And so let's go back to our customer retention problem, where we had that idea that tenure was important. There were other things, other variables that seemed to be important. Okay, so, but let's suppose that now the company say, well, I can't just focus on one thing, right? I'm sure these variables are interacting, so I need to know how they interact and how we can use them to identify customers that may be at risk of leaving, and we want to approach them and say, hey, maybe with some incentives for them to stay. So let's take a look at that. Let's suppose that we had that same data set that we talked about, but now instead of just focusing on one variable at a time, we try to put them all together. And a classification tree is a very convenient and effective tool to do that. So now in this particular tree, we see that we have the three variables that we saw before: contract, service, and tenure. But now what it does is it gives us a way to identify those customers that may be at risk. So, for example, just very quickly here, imagine that we have a customer that is on a month-to-month contract and uses and hire a premium service, well, that seems to be at risk according to this classification tree, and we will have to, work with those customers to maybe see what kind of incentives we can give them. Another type of customer that seems to be at risk here is that those that are month-to-month have a standard package of services, and then they have a tenure that is less than or equal to 6 months, and that the tree is saying, hey, watch out, because those are the two groups that you might want to put your efforts in try to retain. And as you can see, this tree is able to classify any customer in terms of the services they have, the contracts they have, and their tenure. Very useful tool, and that a lot of data analytics software is able to produce given some data set. All right, so let's talk about another type of prediction, which has to do with grouping customers. So this is also known, is very well known in marketing. So let's take a look at the situation. So the situation is that an online retailer, right, is interested in segmenting her customers to better target product offerings. So the retailer has collected data and wants to see if she can identify market segments. So this is why this particular technique is also called data segmentation or market segmentation. Okay, the idea is to group customers in groups where the customers in that group are very similar, and they are dissimilar to customers in other groups. So let's take a look at what data might be helpful for something like this. So let's suppose that in this particular situation that I'm just showing here, you have some idea of income levels and number of dependents and average purchases that the customers have made, say in the last year, and then the number of purchases. All right, so this technique, what it does, as I say, is it creates groups and clusters. So let's suppose that the output of the analysis is this table. This is the key thing that a cluster analysis will produce. And what I've done here is, in terms of giving you numbers here, which may all be meaningless, I'm just putting minus and plus signs and a 0. And the minus signs basically indicate that, for example, for this variable and this group, this particular value was below the average. And a plus sign, the more pluses is the more that value was above the average, and a 0 means that is right on the average. So what a cluster analysis will give you is an idea of, well, how many groups are out there, right? Can we describe them? Are they unique? That's what's important in an analysis like this. For example, just let's say that we got this output out of a data set like that. Well, someone who's below income, and I always present this to our students here, say, well, if it's below income and you don't have dependents, and you purchase below average in terms of the value and don't purchase a lot, well, that must be a student, right? I mean, you figure, okay, that's maybe a profile of a student, while maybe the last one is a profile of a family that is above average in terms of dependents, and they purchase quite a bit at an average value. So this is the idea. So what sort of markets are out there? Well, maybe the profile is we have young people, and then we also have families, and perhaps some young professionals who have a larger income. So very important for marketing purposes to have to do cluster analysis, and it's another tool that's definitely used in business analytics. All right, so the last piece on predictive analytics is given by this example. So let's suppose that you have a situation where a hotel wants to use overbooking for revenue management purposes, right? This idea of overbooking started with the airlines, back in the at least in the 80s, and now is used in many different processes, and in the hospitality industry for sure. So the idea is to come up with a booking limit, right, that will maximize revenue because there will be people who don't show up, but also we have to be careful with this denial ratio. The reason for that is that obviously the denial ratio is a situation where you have to deny check-in to a person who has a booking. That's because you have just run out of rooms because of the overbooking situation, and that will upset customers. So, all right. So what is used often is a tool that's called simulation, and in particular, it's called Monte Carlo simulation. So this technique, the idea is to estimate probabilities of outcomes, and it's very useful when you have uncertainty. The main source of uncertainty in this situation that I'm describing is that you don't know if cancellations come and go, people don't show up for whatever reason, and even though you can penalize them by charging them one night of the room, the idea is to use overbooking to then even extract more revenue from the assets that that hotel has. So let's suppose that the data they have is they have historical reservations, seasonality, cancellations, which includes no-shows, and then length of stay. So if a simulation model is created for a situation like this, the output that we will be analyzing will be something like this, okay? So let me explain this a little bit. This will be the estimated probability distribution of the denials. Okay, so for example, most of the time you're going to be okay, and this corresponds to a particular policy, to a particular booking limit that was simulated. Okay, but in this case, what this is predicting, because these are the 0 denials, 1, 2, 3, 4, and so on and so forth, what this thing is predicting is that 24.35% of the time you're going to have situations with that policy, you're going to have situations where 3 or more denials are going to occur. Clearly the frequency by which the other ones are going to occur is less, because these bars are really small. But still, if you accumulate all these values, it's 24.3% of the time. So that may be a policy that is too aggressive. It creates too many disruptions, because clearly almost quarter of the time you're going to have someone who's going to have to be rebooked in a different hotel. So that may not be a very good policy and needs to be revised. But this is the kind of insights that you get now with more sophistication, which is essentially adding this computer simulation, Monte Carlo simulation, to a situation such as this overbooking idea. All right, so that brings us to our third piece, which is, okay, so now that we have ways of predicting outcomes, even making predictions when there is uncertainty, or very high levels of uncertainty, how is that we're going to make the best decision? Well, this brings us to the area of optimization, and it's also known as decision modeling. Again, this is where I spend a lot of my time and effort and energy writing papers on it. And the main point here of these three, I guess, is, or let's start with the first one, is that there are too many decisions. So the idea is that there is a very large set of possibilities, and that's why you use these tools. And essentially, it's optimization models, right? And which allows you to allocate resources efficiently. And typically, it's because efficiency is measured by lowering costs or by creating solutions that are more profitable. Okay, so let's look at a situation that we're all familiar with, right? Small package shipping and delivery. Now in the world of Amazon, and we all order online and expect or products to be delivered on time. It's a very large industry that is measured in the billions of dollars, and is very competitive, and it also needs to be very efficient, because otherwise it's very hard to make money if you spend most of your resources shipping in an inefficient way. The core of these systems is something that is called the vehicle routing problem. This problem has been studied extensively in academia, but and I'll tell you the next slide about specifically for the small package delivery. But in generally speaking, this problem is about choosing the number of vehicles to use, assign customers to vehicles, and construct routes, and then observe policies such as time windows for these deliveries. So in the world of small package delivery, this is more than just that. It's more complicated, because they worry about customer service. For example, the idea that service providers work in certain territories, and that's just is not necessarily a cost consideration, is more of a customer service consideration. Also, you need to balance the workload of these service providers, because the demand comes in uncertain patterns, and it needs to be balanced daily or weekly. So the other piece here, which is very interesting, and we may not think about it, but is how you even put the packages inside of a truck, right? Ideally, you're going to do this in a way that the items that are going to be delivered first are closer to the doors, and the other ones are closer to the back of that of the truck. So very common problem in operations research that is called bin packing problem, and people have worked on that a lot. Time windows is another thing that that makes the problem difficult, and not every route is feasible, because trucks are just allowed to go to certain customers at certain times. And then finally, this idea that is not static, right? This thing is not static. You can have congestions due to all kinds of things, traffic or construction, and you might have to modify these routes on real time. So how is that companies deal with these things? Well, one of the possibilities is using general purpose software and services. So I'm listing here a few companies that offer services. Some of them offer software, but some of them offer software and services at the same time, in terms of creating solutions for their clients. This is, as I say, general optimization type of services and software. Now, within certain areas, there are plenty of companies that offer specific software. For example, for vehicle routing is a big area of application for operations research, and you can see here there are, I think, 10 companies, and I'm sure this list doesn't intend to be exhaustive. There are many more that offer services, specialized services for routing. And all right, so to leave time for questions, I'm going to now just jump into one little last section here that we actually also emphasize in our course on Survey of Business Analytics course, and is this idea of presenting results, and summarized by this notion of storytelling with numbers. I highly recommend this book, Stephen Few. The book is called Show Me the Numbers. Really, a lot of really good insights on how to create effective charts and tables to summarize numerical data. Here there are 7 concepts that he emphasizes. I'm going to give you 2 examples. One on this idea of simplicity is good, and then another one that has to do with providing context on whatever you present. Okay, so 2 more examples. So this one is actually related here to the lead school and CU in general. So let's suppose that we're looking, and we're very interested in graduation rates, and so I'm presenting this chart here that just shows graduation rates from 2012 to 2016, and then we show the lead school in black, and then arts and science in gray, and CU in general in light blue. All right, so you say, well, maybe this chart is presented here with the idea that graduation rates, the lead school is doing better than arts and science and CU in general, and that things are increasing and we're doing better than we did before. But so that's one thing. But let's suppose that that's not what I wanted to communicate. Let's suppose that what I wanted to communicate is that there was a change here that was implemented that then we're trying to see the effect of that change 5 years later. Well, if that's the case, maybe I just should focus on that and just go like this and not even put a chart, but use text, and I say, hey, this is what's going on. Now we have a 78% graduation rate compared to 61% 5 years ago. And that just kind of drives that point home that things change, improved, because we made this one change 5 years ago. So simplicity is the message for that one example. So let's now talk about another example. So let's say, hey, let's suppose that someone just puts out this sales revenue chart, and it says, well, things are going well. This is the cumulative revenue for the year, and that's how we're doing this year. Yeah, but without context, it's very difficult to figure out whether we're doing well or not, or that company is doing well. So how about showing something like this, right? Where you say, well, not only this is what's happening this year, but this is what happened last year. And by the way, these are the targets that we laid out for this year, and we're exceeding them. So as you can see, there are many examples like that in that book that I just mentioned, and I will encourage you to take a look at them, because they really improve presentations of numerical data. All right, so to close here, shamelessly here, I'm going to pitch for two things. One is this Coursera course that that two colleagues of mine and I put together. And it's actually not a course, it's a whole set of courses within what's called a specialization. And ours in particular is called Advanced Business Analytics Specialization. And there is a link there that Sam is going to share with you later if you're interested in learning more about these topics. And then, of course, you're always welcome to come back to campus, welcome to come back to the Coble building here at the Leeds School, and join our Masters in Business Analytics. That's what I'm currently teaching, and we've been offering for 3 years, and I think it's a terrific opportunity to even learn more about this exciting topic. And with that, I want to thank you for being here with us this morning and or this early afternoon, and I'm ready to take any questions you may have.
Great, thanks, Manuel. And then just a reminder to everyone that you can submit the questions that you have through your attendee portal, and we'll make sure that those get asked of Manuel. So Manuel, question for you here. So what will the impact of the, hopefully I say this right, so let's try this here. So what will the impact of the democratization of analytics and the spread of deep learning, what will that impact be?
Well, I think the impact will be just productivity, one hopes, because increasing productivity, because the more we're able to use our resources better. I mean, deep learning and these tools are about being more targeted in what we do. Now, of course, there is this concern about, targeting marketing because of almost, this notion of privacy and knowing too much about or learning too much about our customers, but is a reality, and it needs to be used with care. But I think if it is, the impact should be increased on on productivity and efficiency of utilization of resources for companies.
Interesting. Great. Thank you. I'm glad that you understood my my translation of the
That's
question.
right.
Another question for you here. So how much of what you're explaining can be done in Excel versus one of the more advanced software programs that you were talking about?
Great. Actually, you know, I forgot to mention that. It's a good that that I got this question, because in the survey for the survey of business analytics course, and in the Coursera specialization that we have, in both of those environments, we use Excel, and we use an add-in to Excel. So a lot of, in fact, the visualizations that I show, they were all Excel. The solution, the simulation that I show was done with an add-in to Excel, which makes this whole process a lot more accessible to people who might want to do some analysis, but they don't want to spend a lot of hours and a lot of effort learning specialized software. Now, certainly in the page where I show specialized software and also general purpose software, some of that does require some learning and some effort, but there is a lot that can be done with Excel, and so that, yeah, thanks for that question. There is quite a bit that could be accomplished just in Excel, and maybe with some add-in tools that complement what Excel offers.
Well, that's exciting to hear. Thank you. And then another question for you. So you shared some different ways to analyze data. How do you go about picking what will work best in terms of the different options?
Right. So I will say the kind of the message that I was trying to give today was this notion that that we want to start simple, right? So it's not about right away jumping on the third level of data analytics and say, okay, well, let's build this super optimization model, right? So the idea is that, can you actually gain even some insight on data exploration? Can you just exploring, visualizing what you have in terms of data that you're able to collect? There are some things that is just, it depends on the problem. Just the tools are almost earmarked for that. Like the one example was this idea, like I want to group customers into particular clusters that will tell me how many markets I have. Well, clustering analysis is pretty much the go-to tool for that. So sometimes it's just about the problem dictates, in a sense, what is available, what you can use or not. Now, let me just comment on one more thing. There are tools that where the idea is that you don't know what's happening under the hood, and the prime example of that is Watson Analytics, that product by IBM. And in that one, essentially, and I have been able to explore a little bit of how that tool works. Essentially, a data set is being uploaded into the system, and it really tries to use some intelligence that is being built into the system to figure out what will be the best way of answering certain questions. And it actually even suggests the questions that you could answer given the data that you have given. So there the tools are hidden, and it's all about, hey, you want to know what drives that, or what are the main variables that influence this other one, and it's trying to really lead you into that. So the tools, I think the tools are very much linked to the questions that are being asked that we want to answer with the data that we have.
Interesting. Great. Thank you. Another question for you. Speaking of tools, so do you have any insight on tools that are available or that are currently being designed to analyze unstructured data, so things like photos or blog posts or what we're seeing online a lot nowadays?
Yeah, correct. In fact, that I go back to Watson. Watson Analytics started with just all numerical and some categorical variables, but now they have a whole area for social media, basically analysis, and the analysis is in text. I'm not sure about pictures. That I cannot comment on that because I haven't seen that, but I definitely know that at least. Watson Analytics has some on text. So the idea is, imagine that you're looking for ratings of products or services, and you are the notion is to go into social media and try to extract what people are saying about certain things and analyze that. So certainly that's part of that system, and I wouldn't be surprised that others are incorporating that. Pictures will be a very interesting thing that I'm not aware of any at the moment.
What was that tool again that you said was doing that?
Watson. That's
Watson?
the IBM Watson Analytics. That's all the commercials you see on TV.
Great.
With Watson, yeah. Mm-hmm.
Thank you. And then another question came in here where this individual they'd love to hear more, your thoughts and a little more around the demand for data scientists versus the availability of jobs for data scientists. So it seems as if the negative unemployment in the industry makes it very challenging for businesses to want to adopt it. So, and if you have any ideas on how to fix the gap.
Yeah, well, yeah, great question for us because we got definitely good ideas on how to fix the gap. In our MS program for business analytics, the gap that we're trying to fix is this notion of data scientists and then the people making decisions, the business problems. So if you're really going to a data scientist program, then it's really about how to create and use tools to analyze data, right? And very, very technical about it. Let's put in the other side of this spectrum, let's put an MBA program where it's not really about the technical issues, but it's about business problems. So what we're trying to bridge with the program that we have is to have people who are very competent on the data analytics tools, but they also know about the business context and how these tools are used in business and what sort of business questions we want to answer with them. So the market for these individuals, at least what we have observed, is pretty strong. We have a very high placement rate for our graduates, and that just indicates that there is demand for people who can do the analysis, but also talk to the C-level folks who might be making some of these decisions.
Awesome. Thanks for that insight. Another question for you. So you had talked about the Monte Carlo simulation. Do you mind going back to that photo when you first introduced the Monte Carlo simulation and just talk more about what that's showing? So I believe it was
this one?
The one before it.
Oh, this is just as surprising. Yeah, this is just well, this essentially what it shows is just say you have an asset here which has this price, and then under some assumptions you create these simulations as to what's going to happen in the future, and these is our paths to some future point as to what that price is going to be. And but if you stop at any point in time in this simulation, you will have a probability distribution of these prices. Okay, so essentially it's just showing the dynamics of how that will work. But at the end of the day, what you get is you stop at one of these points, and that's where you create something like this, which is so this is what will happen, say, in one of those time slices, and then you create a probability distribution of the outcomes. So yeah, that just shows the dynamic of Monte Carlo in a kind of a nice, colorful way.
Okay, great. Thanks for explaining that in a little more detail there. And then one more question for you. So for everyone here on the call today, if there's one thing that they could go back to their businesses and start doing today to start analyzing data more, or at least like one small change that they could make in what they're doing in their day-to-day, what would you suggest?
What I will suggest is that they come up with a question they want to answer. I don't think it's good to. I mean, it could be a good exercise to go to the data first, but I will say, what is something that if we could resolve this, it could really make a difference. And then if you say, okay, so that's the question now, the business question we want to address. And then say, all right, do we have data, or is it possible to collect data to address this question? And then worry about the tools. The data piece, actually, when we teach or survey of business analytics, we tell them you're going to spend probably more time on the data and not only collection, but also managing it and cleaning it up in a way that is useful for then using the models than anything else. And but I will say you have to start with the business question. What is the one thing that I would like to know that I don't know now that I think it can be explained with data, and then you worry about the data, and certainly much later worry about the tools.
Wonderful. Well, thank you. And thank you so much for everyone for joining us for today's presentation. And Manuel, thank you so much again for all of this great information. So I just want to remind everyone that to view upcoming webinars and to request previous recordings, please be sure to visit our website at www.colorado.edu/alumni/webinars. And have a great rest of your day, and go Buffs!